Okay, so for this problem we have a 2 kilogram spaceship, seems awfully light, launched from 0. Thrust is constant until it reaches 21.5 meters, and then it's cut off. We're neglecting air resistance, so that would just be the drag. And we are going to determine the speed of the rocket when the thrust ends. So, if we do force balance on this guy. Okay, so it's gonna have weight, right? Mass times gravity. And going up, it's gonna have force thrust. Cool, and that is all. So we're gonna be using energy and momentum to solve this guy out. So we're going to have potential energy at 1 plus the kinetic energy at 1 plus work is equal to potential energy at point 2 plus kinetic energy at 2 plus work. So, since on the ground there's no potential energy at 0, there's also no kinetic energy because it's not moving. Now, there is work because we're having the thrust work. Work is just going to be force times distance. So it's going to be the force of thrust times the height reached. So that's valid. There's a potential energy term at the end because we have reached a certain height and there's potential energy from gravity. There's a kinetic energy because it's moving. And there's no work because the thrusters are off and there's nothing else happening. So we're trying to find the kinetic energy, so we can balance that by saying that kinetic energy is equal to work minus potential energy at point 2. So that is going to be 1/2 mv squared, 0.2, times 37.7 newtons times 21.5 meters thrust work minus 2 times 9.81 meters per second squared times 21.5 meters. Yeah, so that will give us looks like 1/2 mv2 is equal to 388.72 Newton meters. Now that is just 2 kilograms, right? Mass is equal to kg. So that 2 and that 2 can cancel out, and we can just divide this by a kg term. So b squared is equal to the square root of 388.72. Let's see if our units check out. Meter per second squared times meter per kilogram. And that's going to create square over s squared. Yep. And v then is equal to 19.72 meters per second. Oh, at point 2. Cool. So there's the answer.